Good evening. Welcome to Quantum Origins. Today I'm presenting the first video of my channel, Quantum Origins. It's a video to introduce the channel. And my name is Pani de Gossard. I'm a physician practicing emergency medicine. And I've created this channel, Quantum Origins, to uh, mostly present a book that I published about a year ago in November of 2023. The title is Ways of Nature, How the Trails of Life Expose the Universe. And so it's the themes of the book is are mostly about biology and physics, and those also will be the themes that I will be presenting in this channel. But I don't rule out that at a later time I might present themes related to medicine and health as well. Some of my readers have suggested to me that some form of a guide, whether in the form of a pamphlet or YouTube videos, would be a welcome addition that would help them navigate the many ideas and concepts that I put forth in the book. So I think this channel will present ample guidance and explanations. And I have decided to create the YouTube channel, and among the options I had. And so, as I said, the themes will be biology and physics, and those will be the themes of the many conferences that I will be presenting in this channel. I promise that you will enjoy many novel ideas in those two fields and propositions as well. The book starts by addressing many unsolved problems in biology, such as the origin of life. Up till now, the question of up to the publication of my book, the questions of the origin of life, that question is still we don't have the answer to it. Scientists still don't know how life started on Earth, how this planet, our Earth, transited from a sterile place to a planet that is teeming with life. So that was an open question until the publication of my book, Ways of Nature. The question of the origin of eukaryotes. Eukaryotes are the cells that make plants and animals. Those are cells that are more complex than a bacterial cell. A bacterial cell is very simple. It's a membrane. There's a cytoplasm, and inside of it you have the genetic material, which is just in the cytoplasm. There is no membrane around it. There is no nucleus. The eukaryotic cells are more complex. They have intracellular compartments such as nucleus, such as mitochondria or chloroplast for the plants, for some plants. And so there is that question of the transition from unicellular organisms such as bacteria to multicellular organisms has not been solved to satisfaction. For about 2 billion years on Earth, we only had prokaryotes, which are the unicellular organisms. Some of the unicellular organisms are bacteria and archaea. For about 2 billion years until there was a transition from prokaryotes to eukaryotic cells. And the current theory for the appearance of eukaryotic cells is what is called the endosymbiotic theory, that has been proposed and advocated by the late biologist Lynn Margulis. According to this theory, some bacteria would have ingested or engulfed other bacteria, and those internalized bacteria would become some of the intracellular organisms, such as mitochondria or chloroplast. But this is theory that leaves on the side the origin of the nucleus. So what about the origin of the nucleus? So, and then if you follow my channel, you'll find out that we don't think that the under symbiotic theory as put forward by the late Professor Lynn Margulis is the way that eukaryogenesis happened, is the way that eukaryotes came to this world. As far as we are concerned, the eukaryotic cell did not evolve according to the symbiotic theory proposed by Professor Margulis. Other problem, the history and the evolution of life. We'll talk about that more. The origin of biodiversity, and the origin of biodiversity is basically the origin of the diversity of life, the origin of species, as Darwin put it in his book, in his groundbreaking book, The Origin of Species, that he published in 1859. So Darwin put forward the origin of species as resulting from natural selection acting on random variations. So that's the way species happened by successive divergences from a single life organism. And so with all due respect, it doesn't seem that to be a topic that Darwin could have solved in his time. And then there are many challenges to the Darwinian theory or to neo-Darwinism. So we'll not get into it at this time. But and then what we have our own theory according to which the species that we know of came to this world. So those will be some of the presentations will be put forward in this channel. The Cambrian explosion, the sudden appearance about 550 million years ago of many life forms, of many of the major animal phyla. They happened suddenly and nobody know why. And so the Cambrian explosion marked the appearance of those many complex life forms. And so this is a topic that we will tackle as well. To explain the origin of the Cambrian explosion, or to explain that phenomenon. The definition of life. What is life? Up to now, we don't have a simple, satisfactory definition of life. A definition that would take about a small paragraph or a few lines or one line. We don't have that, and then one that would be satisfactory. It's something that we intend to propose as well. What I found out while I was trying to tackle those issues in biology. So my initial goal in writing the book was basically biology because I'm a physician. But what I found out is that to clarify or to answer some of those questions in biology, I needed to conjure up many notions in physics. I needed to clarify some of the most fundamental questions in physics and cosmogony, such as the origin, the structure, and the fate of the universe. Questions about time and space, questions about gravity, what causing the expansion of the universe, is it dark energy or something else? Regarding gravity, we know that Isaac Newton did propose a formula according that gives the strength of the force of gravity between two bodies in space. But as far as the cause of gravitational attraction, he didn't have a clue. He didn't have a clue, so he wrote in his groundbreaking book, the Principia, that hypothesis non fingo. I'm not making any I'm not making any hypothesis. So that was all until Einstein in the early 20th century, in his theory of general relativity, so came with that theory. He proposed that theory that gravity may be the result of large masses or large bodies curving, warping time and space. So he didn't think that gravity was a force, but it was I think that it was caused by the curvature of space-time. That the real answer? We still don't know whether that's the real answer to the cause of gravity. We know the formula. We can calculate the strength of gravity between the sun and the moon, or I mean the Earth and the moon, or the sun and any other planet. But what caused that? It is well, it's spooky action at a distance. We don't know, because there is that in between, that empty space between Earth and the moon, or between the sun and the Earth. What keeping the planets in orbit. So it's a question that Newton admitted that he didn't really have the answer. Einstein gave us an answer, but yeah, should we rest on that answer that Einstein gave? Um, I think that one of the major flaw of going back to biology, one of the major flaw of the theory of natural selection that was put forward by Darwin, and then that was further, there was a major synthesis with the neo-Darwinists. One of the major flaw and the major gap of it is that, according to the theory of natural selection, if you look at the theory of natural selection, life is not put in the context of the physical universe. Life is not. They don't place life in its physical context. Life is submitted to the vagaries of random variation, random genetic variations, or random modifications, the way Darwin put it. But if you look at the universe, but the universe is a lot like the universe is a lot like the universe is about 13.8 billion years, and life is about on planet Earth is about 3.5 to 4 billion years. So 10 billion years into the evolution of the universe, lifetime period in a universe that was expanding, in a universe that's getting cooler, in a universe where entropy is increasing from the Big Bang on the left to where we are now on the right. So about 10 billion years here, about here 10 billion years, life appear on Earth. So life appear in the context of a low-like universe where, as I said, the universe is expanding, is getting cooler, entropy is increasing, and we have a fixed speed of electromagnetic radiation. But according to the theory of natural selection, life is random. Does that make sense? The randomness of life in a low-like universe. So my suggestion rather is that we have to expect life happening in the universe. It has to be low-like as well. So now you may ask the question, why the name quantum origins for the channel? The concept of quantum origins is new in the channel. Is new. It didn't appear in the book, but it was after a period of reflection that I found out that three origin questions that are addressed in the book can be encapsulated in the concept of quantum origins. Basically, that those three entities of phenomena, meaning the universe, life, or complex life, meaning the eukaryotes, multicellular organisms, they originate from their from their most simplest form, from their quantum state. Hence, the concept of quantum origins. And in fact, I'm putting forward a theory called the quantum theory of origins, that will be in the I hope in the next edition of the book, that will state that the universe, life and complex life, it started in the respective quantum state, in the smallest possible state. I did explain the complex life, eukaryotes, according to what I call the seed first theory, but I'm going to put them under those three phenomena under the hat of quantum theory of origins, which I will table on to explain the origin of the universe, the origin of life, and the origin of complex life. You might ask, so why not wait for biologists and physicists to solve these major problems I talk about mostly in biology and physics? You might ask, why shouldn't wait for the specialists to solve them? My answer is to that is sometimes we need fresh minds to attack some problems, to tackle some problems. We need people to think out of the box. Not that I say that biologists or physicists cannot think out of the box. They can, but at times you may need people out of the field to really solve some major issues. Einstein, when he came up with his theories of relativity, he was initially he wasn't in the mainstream of physics. He was a patent clerk. He was working in a patent office. He wasn't. He was not among the physics world intelligentsia, and scientists are usually molded by the doctrines of what Thomas Kuhn, the philosopher of science of the one of the philosophers of science of the 20th century, what he called normal science, what we call the current paradigm. And then sometimes you need, as I said, you need a paradigm shift. And people that are not in the field may have a certain advantage to really provide this paradigm shift. And I think that's what we have provided in the book Ways of Nature. And sometimes if you attend a conference of any discipline, I'll give an example of evolutionary biology. If you attend a conference and you'll find out that the biologists, they are all entrenched in Darwinism or neo-Darwinism. It's like they're unable to undermine the foundations of a tower on which they stand. All their studies presuppose Darwinism. All their studies, their presentation, their thinking is rooted in Darwinism and neo-Darwinism. So it's hard for them. I think it's hard for them to undermine that foundation, because their theories will collapse as well, because that's what they sit or stand on. So why then a physician? Why then a physician should be the one to tackle those issues, to tackle those problems? My answer is, why not? We physicians, our object of study, which is the human body, the human being, is in health and diseases, is from the human zygote to human consciousness, is one of the most complex systems in the universe. We study one of the most complex systems in the universe, so we do have the credentials. If we are interested in some other problem in science and physics, that we can put our mind to it. So we do. I think we do have the credentials that we can tackle those problems, and we can make whatever contribution, small or large. And I will take to end, because today it's just introducing the channel. I will give some examples of physicians or medical school alumni, people who are just medical students, who finally gave major contribution to science, to non-medical science. So people who were in medicine, whether who practice or didn't practice it, gave major non-medical contribution to science. I will start with Galileo Galilei. He was a great scientist in Italy. He was born in Pisa, Italy, and so his life spanned the late 16th, early 17th century. He did enroll at the medical school in Pisa, at the University of Pisa, but he gave up studying medicine to study mathematics and natural philosophy. Natural philosophy, which was basically what we call science today. So some major discoveries that he made using the telescopes. He was the one who discovered the 4 major moons of Jupiter. He discovered the spots on the sun. He discovers mountains on the moon, and also one of the major experiments he made that still taught to students in physics is the inclined plane experiment, the rolling a ball down a ramp. Excuse me. So here we have a previous medical student who made major contribution in science. Jean-Baptiste Lamarck, he studied medicine as well for 4 years, but gave it up. But he came up with, he is known mostly for his theory of evolution by inheritance of acquired characteristics. So we know that his theory will be discredited at a later time when it was replaced by the theory of natural selection by Charles Darwin. So he explained that in his theory that modern giraffes have a long neck because their ancestors, previous generations of giraffe, were stretching their neck to reach higher and higher leaves, particularly in periods of food scarcity, trying to reach higher and higher vegetation. And those characteristics they were able to transmit them to their offspring, and then that's how, with successive generations, stretching their neck, a longer and longer neck, that explained why modern giraffes have a longer neck in modern times. So that was the theory of Lamarck. Was a French naturalist in the late 18th to early 19th century. Thomas Young, he was a physician. He studied medicine. Was a British polymath, they would say in French, a universal spirit, and an esprit universel. And his lifespan, the late 18th to early 19th century, was British. He was the one. I have to put it in context. Before him, we had Isaac Newton, who came with the theory that light was a particle, that light was made of corpuscles, he said. So we had a corpuscular theory of light, but he came in and did a famous experiment, which is very famous in the domain of physics, particularly in quantum mechanics, and we called the double slit experiment, where he demonstrated that life was also a wave. He demonstrated the wave nature of light. And then it's basically shine a light against a barrier that has 2 slits in it, and then we had a photographic plate in the back that will capture the light, and it shows a pattern of interference. It shows showing the pattern of interference that is typical of waves, where we have reinforcement, where where 2 waves collide, and then we have cancellations where the trough, where we have 2 troughs that collide. The reinforcement where we have 2 peaks. So it's a pattern of interference that demonstrates the wave nature of light. We can see here we have the pattern of interference in the back. We have cancellations, so it's dark, and also additions, which are light. So wave nature of light that he demonstrated with his double slit experiment. Charles Darwin also was a medical student. Was a British naturalist of the 19th century. 19th century. He came with a theory of evolution by natural selection. He was a medical student, was enrolled at the medical school of Edinburgh, but he left medical school because he was disgusted by the practice of surgery. At the time, we understand where surgery was practiced without anesthesia, and so he disliked medicine and left, and said gave himself to natural science. So we well know that his magnum opus, The Origin of Species, that was published in 1859, in which he exposed his theory of evolution by natural selection. He says again he was a medical student. Last but not least, We'll talk about Stoughton and Kaufman. Dr. Kaufman was actually he's an emergency medicine physician, was trained as an emergency medicine physician, but he devoted his time mostly to theoretical biology. And one of the things that is famous for is to come with the concept of autocatalytic sets, autocatalytic sets. So he studied complex systems, and he was able to he came up with a theory that life, which is a complex system, may have originated from a complex set of chemicals in the prebiotic area that would interact and would come with an emergent property that we know today as life. So, and then this concept of the catalytic sets, I think I proved it. I proved it in my research, and so it's a concept that I use in my definition of life. He made a significant contribution of finding that life, like he said, even economies, they originated from the interactions of parts within an organized system. It's a very interesting concept, and again, he's still alive, and he's a American medical physician, medical doctor. And so there will be a lot of content in this channel. There will be many more presentations to come, and I invite you to subscribe to the channel so you can be abreast of the new presentation. And this video today was just an introductory video. And I will say that if there is something new in the channel that you notice and you want to cite in an article or wherever, so you can cite the channel or the specific presentation. In summary, that presentation was to introduce the channel Quantum Origins. There will be new ideas in biology and physics that will be presented in this channel. And we thank you for your attention. Until next time, thank you.